We did the first few up here. Were there any questions on these? You had a number of ways. If you don't like dropping them down, then take the log of both sides and bring it down. Just be careful to keep that 2x minus 7 in parentheses. Anything with an e, isolate it. Take the ln of both sides. In a, you have to use ln. You can use ln for anything, but an e has to use ln. You have a number of ways to do this. You can flip this and then just solve it. You can put it in. You can do an intersect in your calculator. If you have two pieces, you could put this in your y1. You could put this in your y2. You can intersect to see where they intersect. They're equations. If you set them equal to each other, then they have to cross at the same point. Probably the easiest way is to bring them down. If not, take the log of both sides. Remember, this is an equal sign. So whatever you do on one side, you have to do to the other side. Then divide them both by log 4. This changes your base into a base of 10 as well. It keeps it into your base 10. I think we did this one in class with the fractions. And this one, I always find it easier to get rid of your fraction. What's going to cause that to take its reciprocal is that -1. So right away, flip this over to the -1. And then it's more doable. You can tell your base 7 squared. Just remember to raise that to the -1. And after you get your answer, just plug it in and check it. It's very, very checkable. It's an equation. Very checkable. Okay? These guys, easiest way, log equals exponent. If you forget, log equals exponent. Your base, your exponent equals x. Easiest way to flip them around. Can you put it in your y1 and y2? Sure. Question? For number 12? So ask me again, I'm sorry.
What is the -2?
See this negative exponent? So say you take the log of each side, right? Now, when you bring this down, it says this, -t/2 log of 5 equals the log of 0.2. When these are being multiplied, the one thing that will help you get rid of your fraction is if I multiplied this guy by 2, right? I'll get rid of my fraction. I would have to multiply this guy by 2, not this piece right here. However, I'm still left with a negative, and I'm going to have to then divide by a negative. So if I can multiply by a -2, it just helps me get rid of that. And you can do it by invert this by log 5 over log 2, but then you're dealing with a fraction within a fraction. So I would get rid of your fraction first. Get rid of that with the negative. This guy is being multiplied over here by your -2. And then it's easier. Divide by log 5. But I find the fractions are easier just to get rid of rather than figure out how do I divide by this thing that has a fraction in it. You know, if I want to divide by a 1/2, I've got to flip that over. So get rid of it up front. This guy too, be careful. This one has to bring this down too. The one thing that I find where everybody slips up is right here. You put in your calculator this. And if you don't put parentheses around that denominator, you get the wrong answer. Because your calculator will say ln 360 divided by 3. Then it will multiply it by ln 8. Anytime you have a grouping, you have to put parentheses around it. Plus, anytime you hit the word log or ln, it gives you a parentheses to close. So you have to put the number in there and don't forget to close it. Before you hit enter, look at your statement. Make sure it is what you want to do, because the problem is this. I put this in my calculator, this is what I got. If you don't put it in your calculator correctly, you can't possibly get the right answer. So make sure before you hit enter that you get it in there correctly. Okay, these got a little bit more involved. Remember we said yesterday or Tuesday, isolate. So add 13 to both sides. I divided by 5. You can take the log of both sides and then use a product. That's probably the better way to do it. I took the ln, just like I told you, sometimes I use ln, sometimes I use log. I want to show you they're interchangeable. Bring this guy down. When you bring this down, that is a factor. So if you need to, divide by ln first. Get that factor out of there, ln2. Just leave that there. I would not reduce this. If it reduces to a decimal, you could, but you can just leave it as a fraction. Do all your reducing at the very end, just like we did in Algebra 2. Then you're going to subtract the 3 from both sides, get rid of the negative x, so you're multiplying by a negative 1, and solve for x. And again, when you put this in your calculator, be careful of your parentheses. Be careful of parentheses. Then probably was just a little messier. Number 14, take the log of both sides. Whenever you have a variable in your exponent, the only way to bring it down is a log. ln or log. Bring it down. Again, when you put this in, look at all the parentheses you're going to need here. You're going to need that separate set of parentheses around there. Good so far? Questions so far?
Doesn't say x 8 minus x.
13.
On the first, like 5 and then parentheses.
3 minus x. This is your exponent, 3 minus x.
So what is the 2? Oh, wait, no, not 2.
The 2 is the base. So we take the ln of both sides, and then this exponent has to come down. My advice was get rid of your ln2 first, and then do your subtract 3, divide by negative 1. Aaron? On 15, this guy looks kind of like this. Let's take this out of here. If I gave you just a simple quadratic, wouldn't you say x minus 5, x plus 1? Right? These exponents are 1s. When you multiply these, what is the rule with this exponent? You add them. So technically you take this and you divide it in 2, because you wanted 2 equal parts. So technically you take this guy, this exponent, you divide it by 2, and what do you get? X. So both of these are e to the x. E to the x minus 5, e to the x plus 1. It gives you 2 sets of factors. I know this one was hard, and it's a pre-calc honors problem, but I put it in there so that you get challenged a little bit. God bless you. It has the same rule as this, but what happens is when you see x squared, you don't think to yourself divided in half because you say x1, x1. But go through and say it out loud. How did I get this x1? Because when I added these, I split them in half equally, right? So split this guy in half equally. So it's e to the x, e to the x. When I multiply e to the x, I keep my base and I add my exponents. 1x plus 1x, 2x. So all we're doing is basically solving 2 separate factors for this.
For 14, how did you get rid of the log 2?
We didn't. We took the log of both sides, and then we needed to solve for t. These are multiplied, so we divided both sides by this. I just didn't rewrite it on that side. We divided both sides by this.
Oh.
This has to have parentheses around that denominator. And I wouldn't put that in my calc if it doesn't come out to be a rational number, like if it doesn't terminate. Leave your rounding to the end. Okay. This one I know was difficult, but it was just a little bit of a thinking problem. And again, if you noticed right here, you have ln of negative 1. You can't take the log or an ln of a negative. Because if you remember, your domain is from 0 to infinity. You can't take the log of 0. You can't take the log of a negative. So So it does make sense. Questions? No? Okay. Alright, let's take a look at these guys. ln is there. You can't cross it out, and you can't get rid of it. If this said log 4x, you would still say log equals exponent. Your base of your log was 10. What's the base of your ln? E. If you want, you can technically raise everything to e raised to both sides. That will work as well. I don't really like that way, but I usually use this way. I just put my base to my exponent equals my 4x. Keep it consistent. This one had a little bit of a domain restriction in here, but I didn't really care about that when you did it. Because your domain says you can't make this 0 or negative, so we were okay there. 10 to the 2, raise it, log equals exponent. 10 to the 2 equals this. 10 squared, just solve it, and check it. Look how nice this is to check. 103 minus 3 is 3, is 100. So what's the log of 100? The log is your exponent. 1 times 10 squared. There's your 2. The log is 2. Okay, this was a nice one. You had to condense these down, make it say log, log. It's got to be one term, before you can take those logs away. We put logs there for one term, and take them away, one term. And remember at the end to check. Always check. Questions?
Is -2 rejected too?
-2, let me see. If we put -2 in here, yep, they're both rejected.
It can never be a negative, right?
Can never be a negative. So therefore we have no solution, right? And see what our domain told us? Our domain told us it had to be greater than 1. So these aren't. So we have to say no solution.
Still having a test tomorrow?
No.
We just have a festival.
We were, but we lost 2 days already. We lost 2 days this week. But we lost 2 days, so I can't possibly give you a test. Okay? Get these equations down pat. Condense the left side. When you subtracted your exponents, you were dividing. Make that your quotient rule. Set it equal to the right side. Once you get one term, you can take them away. And then you've got a regular equation. Cross multiply this guy. Just remember to keep this in parentheses. Cross multiply and solve. Now, we couldn't factor this, so I used the quadratic formula. Now, we're going to automatically reject the negative because we can't have a negative in there. And it's going to have to be bigger than 2. That's what our domain has to be larger than 2. So if this one came out to be larger than 2, we at least know that could be doable. And here's another thing. When you put this in, if you put this in with 3.303 when we round it, remember it's not going to be exactly both sides, but it will be in the ballpark. Okay? And your last one, you only have ln on one side, so get that down to one term. When you get down to here, you have to then say log equals exponent. 10, well, base 10 in the log, base e in ln. E to the 10 equals this mess. And that one wasn't the greatest one to do, but if you can get that far at least, that was fine. If you just get that far. You can put that in your calculator, I guess, but find a 0. If you didn't get that, I'm not too concerned. Tomorrow, guys, make sure to go over these today. Tomorrow we're going to hit your application. And then wrap that up and probably test on Tuesday. We have to get finished with these logs sometime.